Hi, everyone. Welcome back to The Future of Energy, a monthly webinar series presented by the Denver Museum of Nature and Science and the Institute for Science and Policy. I'm Trent Noss, managing editor with the Institute, and we're delighted to have so many of you joining us again here today. We're rolling into episode 6 of this series already, unbelievably, and today we're going to be discussing buildings and how structures fit into our energy landscape and what's ahead for sustainability and design. I'm very fortunate to be joined by two great guests from Colorado today, whom I'll introduce just momentarily. And a couple of housekeeping notes before we get started. For those of you joining us on Zoom, remember to send in your questions throughout the presentation using the chat feature. We love to hear from you, love to know what's on your mind. Please don't be shy. We will accumulate them and get to as many as we can by the end of the program. Thank you to those who already sent in questions with your registration. We've got those queued up as well. And secondly, this episode will be recorded and made available on our YouTube channel after the fact. So if you want to revisit any of the information that's presented today, or you want to share it with a friend, that's of course welcome and encouraged. So today, it's no exaggeration to say that buildings are a huge piece of the energy puzzle, both in terms of their construction, their operation, their form, and their function for their occupants. So when we think about the role of the built environment in terms of climate change and CO2 emissions, there's a lot to consider. And historically, buildings have been a major sector, very carbon heavy sector. In fact, there was a UN-backed report that was released in December that said that emissions from the operation of buildings hit their highest level ever globally in 2019, which is the year that the data was looking at. But on the other hand, buildings are these incredible canvases for creativity, for innovation. We've seen incredible advances in both design and technology that have allowed them to become more energy efficient and trend toward more of what we would consider a net zero emission profile. We've also seen the effects of various incentives and mandates and building codes and market forces at state and local and national levels. So there's a lot to consider, a lot to get into. And I'm very pleased to be joined today by my guests, the first of whom is Josie Plaut. She is the Associate Director for the Institute for the Built Environment at Colorado State University. And she guides companies, municipalities, and organizations through developing capacity and action plans for regeneration and sustainability. Her work spans domestic and international projects and organizations across a variety of scales, including buildings, master plans, municipal programs, community coalitions, and organizational development. Josie, thanks so much for being here.
Glad to be here. Thank you, Trent, and thank you all for joining us this afternoon and evening.
Great. And we're also joined by Jamy Bacchus. He is a mechanical engineer, energy modeler, sustainability consultant, and policy advocate at ME Engineers, a nationally renowned design firm that has worked on some of the most recognizable buildings in the country. Jamie's passion is mitigating the energy-related impacts of the built environment, and he has over 25 years of experience designing HVAC systems for green buildings and net zero energy projects. Hi, Jamie.
Hi. Can you all hear me?
Yep, all good.
Great. Well, glad to be here.
Well, thank you both. And we're going to start with a little bit of presentation. So Jamie, I'm going to turn it over to you and please take it away.
Great, thanks. So we wanted to do a little bit just to set the stage for where we are and how we got here. And share screen. See if that works. Slideshow. Are you all able to see that? I can no longer see you.
I am not seeing
Trent,
it.
are you able to see that? You're not?
Not at the moment, no.
Oh, let's try it again.
There we go.
All right.
Perfect.
So we wanted to just take a little bit of background and historical context before we jump into the future of buildings and their energy use and carbon impacts on the environment. Looking back, what did we use as energy sources in buildings? It was largely wood and biomass, coal, gas and oil. And then you had some amounts of renewables in there, sun, wind, water. And then 1880s, we started electrifying our buildings. And we had the war between Edison using direct current and George Westinghouse at alternating current. George Westinghouse won, electrified the Chicago Expo, and we're only seeing a resurgence now in direct current in the shape of microgrids, because photovoltaic panels are inherently producing direct current. Our laptops, our phones are all based on technology that use direct current, and so you're now seeing direct current come back into flavor, but largely we are operating in an alternating current universe. Some people may be old enough to remember the 1950s and 60s when the promise of nuclear power was too cheap to meter, that we would just have infinite power. And then we all know how that worked out. There is a great set of Sankey diagrams from the University of Chicago that show in an animation form of our energy use in the United States over time from 1800 until today. I'm going to take a few snapshots just to show you here at the dawn of the Industrial Revolution in the United States. Virtually everything that we're consuming for energy is biomass. It's all trees. There's a tiny bit of coal, some hydro powering some mills, and then transportation is largely wind driven or it's animals or your feet. And then you jump 50 years ahead and you see that biomass starts shrinking. Coal starts beginning to be used in our homes, in our industries. You jump another 50 years ahead and you see that coal is now taken over almost every sector. So steam powered trains, ships, industry, and our homes and businesses. And biomass has shrunk considerably and oil has started to take off. And you also see now the nascent electricity sector, which is largely coal powered. Jump ahead again another 50 years, you see that natural gas came out of nowhere and is now powering our homes, our buildings, our industry, and our electrical sector. And oil has taken over the entire transportation sector. There's no more coal, except coal going into power plants and industries. And then you step another 50 years to essentially today, you see nuclear has come online. Coal has now been relegated just to the electricity sector. It no longer goes directly into our homes and businesses. Petroleum is still king when it comes to traveling, whether it's air, ship, rail, or automobile. It's all oil-based. And then nat gas has taken over and displaced a lot of the coal in the electricity sector. So that's kind of where we are right now as a nation. And if we're going to decarbonize our buildings and our electric grid, then we have to get rid of all of that gas going into our homes and businesses and the electric grid and the oil going into our vehicles. So that would look something like this. You've got to take the oil out of our transportation, take some coal out there of our electric grid, take some nat gas directly out of our buildings, take it out of our electric grid, replace it with solar, put a lot of wind in, and you see the scale jump in our electricity grid, how much more capacity we need to add. And then we're now powering our transportation from those buildings instead of it being completely divorced with oil filling stations and gasoline filling stations down the street. You are now powering your building, your vehicle fleet from either your home or your office. And so the transportation sector is now going to have to ride on the backs of those buildings, which are now going to be wired for this. And so that gives you a sense of the scale of what we're looking at, trying to accomplish for these cities and states that have 2050 targets and goals to decarbonize. You've got 30 years to get a really far place away. If we just want to take a look also at the energies within our homes, you see that we were, during, this is essentially from the baby boom up until today, you see that our homes were consuming considerably more and more energy year after year until the oil crisis, in which case the advent of the original energy codes for buildings came into being, and that's kept the growth of energy use in buildings kind of in check, that we've essentially remained flat in our energy use when you take into account population growth. And if you want to look at what kind of fuel we use within our buildings, you see that the South and Southeast of the United States is more likely to have an electrically heated home and domestic hot water system, whereas the rest of the country is still largely using natural gas and fuel oils and some biomass to heat those homes. So decarbonizing our homes and our businesses is another huge task. If you want to look at how we generate electricity as a nation, you kind of saw it earlier in that Sankey diagram that I was showing. This shows it for the last 20 or 19 years, a little more cleanly, that it was mostly coal. And as coal has become out of favor for greenhouse gas pollution, we are now increasing our amount of natural gas in our electricity sector. While nuclear is there, but a lot of our aging nuclear fleets are going to be decommissioned by 2050. So what are you going to replace that with? So you could see that a huge chunk of our electricity sector, how we generate energy, has to change if we're going to hit any of these targets. And then looking specifically at Colorado, 20 years ago, we were essentially an all fossil fuel-based grid. We only had coal and nat gas with a small amount of hydro. All the wind and all the solar that you see if you drive around the state is essentially fairly new on the grid. And it's still, we might hit days on windy days with low demand, 30-ish% of renewables in our grid right now in Chicago or in Colorado. It's still not displacing a lot of the carbon intensive fuel sources that are in that mix. And I thought I'd just throw this out since we're going to be talking about net zero a fair amount. Net zero in layperson's terms is essentially the amount of energy you're using on site, you're also generating. And that's not always on site, but it can be. And essentially you're just reducing your energy footprint more and more, and then adding on photovoltaic panels or renewables until those two meet. And then at that point, you could be considered net zero, and beyond that, you're energy positive. And with that, I'll hand it over to Josie to continue with some of these.
Thanks, Jamie.
Sure.
All right. So, so change is on the horizon. Jamie, thanks for kind of taking us through some of the history. And it's, you know, it occurs to me that the energy world has been changing rapidly since the early 1800s. It's these big changes actually are nothing new. It's a sector that has continued to evolve pretty rapidly. So I'm going to share with you all two big trends and a little social science. Oh, if I can get my slides to advance. Before I do that, IBE is an institute at Colorado State University. We've been around for about 25 years, and we help to advance the development of healthy, thriving built environments, including buildings and communities that are low energy, resilient, and good for people and other living systems. The future of energy and greenhouse gases and carbon are deeply entwined. So we may use these ideas a little bit interchangeably, although they're not exactly the same. But this pie chart here shows the source of greenhouse gas emissions in Denver. And you can see that the bulk of greenhouse gas emissions, and thereby the energy use, are from transportation, commercial buildings, and home and industrial buildings. And you can see that 64% of greenhouse gas emissions in Denver are the result of buildings and the energy that we use inside of them. So those are all tied back to the electric grid that Jamie was mentioning. most of the buildings that are built today will still be here in 50 to 100 or more years. So by building super efficient new buildings, we reduce the total need, and we reduce the need to run that building for the life of the building. To get to all the way to net zero, buildings then need to install enough renewable energy to cover their own energy needs. And in this way, zero energy buildings can essentially create their own energy for the life of the building. It also points to the need to begin with starting to build new buildings in a way that will stop being a burden on future generations. So let's look a little bit at the pathway toward decarbonizing the building sector. This illustration is from the World Green Building Council, and it shows the pathways that we need to follow to start to move toward a zero carbon built environment. First, the first goal or the first stop along the way, and these things don't happen, you know, in isolation or in boxes, but we really need to make sure that we start building new buildings in a way that operate at net zero carbon. In order to do that, we need good government engagement. So those are policies and goals and targets and regulations. We need training and education for practitioners like Jamy. Now, Jamy is at the head of his industry, but not every engineer has the skill set that Jamy does to create these very low energy buildings and net zero buildings. So we need to work on educating the workforce. That also includes contractors and architects and developers and banks. So we need to kind of bring industry along. And then we need corporate engagement. We need leadership from organizations that are both creating technologies as well as leading the way and showing what's possible. And that's part of how we get to this 2030 goal of all new buildings being net zero. And then this bigger, more audacious goal actually of all existing buildings being net zero carbon by 2050. And that is its own massive challenge because it's actually pretty, there's a lot of building stock that already exists. And so that's going to require a lot of weatherization and retrofits, replacing existing mechanical systems, and a whole new group of workforce to be able to help those buildings transition over. So this is hot off the press, just published a few weeks ago. Denver is working on implementing a plan and a code and amendments to the building codes that would make new zero energy buildings a requirement in just 9 years. So not only would all new buildings need to be net zero, they would also need to be all electric, and they would need to be able to send and receive messages from the grid. So there are a number of ways that this shift is going to require different things from the grid. I'm going to talk a little bit more about electrification in just a minute, but it is important to say that there are additional efforts happening in Denver and around the country for those of you who are joining us from other locations around achieving both electrification as well as how we start to move that existing building stock to zero energy or zero carbon. So the second big trend is electrification. And electrification is going to need to happen at the transportation sector. We're already starting to see that. And Jamy was mentioning the shifts that need to happen as far as the ability to store, to charge and store electricity more so at our places of work and at our homes than we have before. It also creates a huge new demand on the electric grid and the electric system than we've seen previously. So that's going to have to cause some big changes. We need to change how and where we're creating energy. We also need to, over time, upgrade our appliances and our heating systems in our homes and our buildings to cope with shifts in supply and demand, and to basically move ourselves away from natural gas appliances. And then we're going to need smart meters and growth in distribution of how energy is both produced and stored. So a lot of improvements there, as well as, like I was saying, this sort of connectivity that needs to happen between our buildings and our appliances and our charging stations and the rest of the grid. So some of you might ask about natural gas. You may love your natural gas stove, but there are some real concerns, and over time, those will become a thing of the past. We can't continue to use natural gas because it's non-renewable and it's a limited resource. It creates greenhouse gases, which are creating a lot of other issues for climate. And then a lesser known fact about natural gas is that it emits nitrogen dioxide, and that creates pretty serious health concerns, especially for children, including increased risk of asthma, respiratory disorders, heart problems, allergies, and cancer. So as much as we may appreciate those gas stoves and think we need a gas furnace, over time that's going to shift and change. All right, now for a little bit of social science. So I promised you two big trends: net zero energy buildings and electrification. Now we're going to talk a little bit about social science and how change happens. And we'll kind of cover how that works from individuals to systems and the structures that form our society. So I'll present these in a linear order, but they're deeply intertwined and have feedback loops between them. So the first one I'm going to talk about are the systems and structures, and they do a lot to define what's possible in a given community. And that's why we work on things like changing codes and improving technologies, because they set the minimums, the standards, and sort of define what's possible. So by changing systems, we can begin to change the bigger picture. Now, in order to do that, there are a lot of networks and relationships that are kind of the informal structures, but they're how influence happens. So relationships between actors include things like social norms, and social norms can be characterized by when in Rome. It's this idea of kind of peer pressure, and when you see other people engaging in a particular kind of behavior, humans are actually kind of pre-wired to want to be like each other. So it's kind of where peer pressure comes in a little bit, but it's also where ideas like peer-to-peer learning come into play. So Jamy is better prepared and better able to teach other engineers than he may be able to reach out to those within the transportation sector, because he has credibility in that field. He can speak their language, he knows the constraints and the materials that they're working with. And so peer-to-peer learning is a really important part of those network relationships and how change happens at that relationship or knowledge sharing level. And then the third area, and where a lot of change efforts are focused, is on individual efforts. So who we are is important, especially because those affect those bigger relations outward, right? So if I can conserve energy, that's great. Or if I can create a model green building and show people that it's possible, it's relevant in so much that I show other people it's possible. But we need individual actors making those choices to build those model buildings and to lead the way. And then all of these start to feed into each other through a series of feedback loops. So this is the last slide that I have on social science, but to be most effective, the interventions that we take to create change need to be matched with the barriers to change. So for something as complicated as net zero buildings or electrification, information alone is not going to be enough to create change. For many, especially those who are resistant to these ideas, new codes will be required for them to change their practices. But in order for that to happen, we need groups of leaders who are able to show that it's possible. So that's where these peer-to-peer relationships come into play, where groups can overcome barriers together and they can learn from each other and continue to advance their knowledge or compound their knowledge on top of one another. that way we can make net zero buildings and electrification possible by using social science to help inform how people relate to each other, how people relate to systems, and how those things all start to come together to move everything over time. So hopefully that gives you a little bit of an idea into how we think about change from a social science perspective. And to sum it up, the two big trends: zero energy buildings, electrifying everything, and being smart about using social science as a lever for change so that we can see how these technologies and people and practices all relate to each other to move us toward that clean energy future. So that's what I've got. Happy to start looking at and taking questions.
Great, thank you so much, Josie. That was terrific. We have a lot of great questions coming in. We're going to try to work through as many as we can here. And maybe we'll stick with just the very ground level residential level right this second. I'm going to try to combine two questions here that speak to both sides of that social science consumer behavior model. We had a question from Ben, which is, what is the biggest hurdle in getting homeowner buy-in? And then we had a question from Melissa, which is, if a homeowner has $10,000 to make their home more sustainable, where would they even begin? So those are kind of the yin and the yang of what we're talking about here. So maybe, Jamy, I'll put this to you first. What are some of the educational tools, some of the consumer information strategies that actors in this space can use to let consumers know even what their options are when they're thinking about, okay, I don't want my gas anymore, what can I get?
That's a great question. And I don't know if the Colorado market has invested in that type of knowledge solutions database. The California investor-owned utilities have, because this has been part of something that they've been doing for a number of years now for energy incentives. So I would go to Xcel Energy first and see, or if PRPA or whomever your local electricity provider is, and see if they have that data or any programs and rebates and incentives for that. I mean, traditionally, you'll see things that like Energy Star appliances that have rebates for them, and those might exist. I believe a rulemaking at the Energy Commission or the Public Utility Commission is allowing fuel switching, which would mean that if you had a furnace in your house, you could then get an incentive to get rid of the gas furnace and put in a heat pump. That is something that the utilities in California have already kind of gone through, so that they can offer monies to fuel switch. In the past, they've been prevented from doing that. So that is, if you're just looking to replace like for like, you could certainly go to them for things. But if when fuel switching gets involved, it's going to be a little murkier on what is allowed. But I would definitely go to them as the first shop. SWEEP, the Southwest Energy Efficiency Project in Boulder, also is our local regional energy efficiency outlet. And they try to keep track of various policies and incentive programs too. We're also lucky to have NREL in our backyard, the National Renewable Energy Lab, and we're also lucky to have Rocky Mountain Institute in our backyard. So from those standpoints, we have advocacy groups and national laboratories in our backyard that do have this type of research or knowledge in-house.
And then Josie, maybe to you, to the other half of the question, to dig in on what are some of the strategies that we can use to reach those who maybe just have a built-in resistance to the idea of change. They have something they like and they don't want to do anything differently.
So I want to speak to the first question just a little bit, and then I can come to that. The first part of that is I would suggest if you are interested in your home, get a home energy audit. Some of your utility providers will provide them for free or reduced cost. And that's a specific plan for you to be able to upgrade your home. And some of them, depending on your municipality, even have on-bill financing. So they can help you to pay for those home energy improvements and just put it on your bill. So essentially it can be a low or no cost to you to upgrade your home. So definitely look at your incentive programs from your local provider. Get a home energy audit, and that will help you to prioritize what to do. The third thing I'll say is electrification is coming, but it's not quite here yet in most places. So the incentives and the programs for that are just down the road. And you may be better off to wait until those incentive programs come online, and that'll help cover the cost of fuel switching if your municipality or power provider doesn't have that. For people who are especially resistant to change, that's where codes and regulations will often come into play. So that's sort of the way to raise the bottom of the bar for everyone. The other way to do that is by really understanding the barriers and starting to overcome them. So in home energy programs, one of the things that we learned was that people were overwhelmed with all of the options. So this isn't someone who's maybe completely resistant, but we found that people were overwhelmed. And so we gave them good, better, and best options in packages. And we just made the decision-making process simpler. And it turned out that a lot of people would choose the better and best options given the choice. So sometimes it's just about making the choice more clear. So depending on the audience and what their resistance is, some people will never change until it's the law. Other people will change if you can just make the choice simpler for them. And then some, just are ready to do it right away.
Well, and go ahead, Jane.
There was like a third part to that question, which I just want to talk briefly about. Of if you had 10,000, what would you spend it on? And first, I would say yes, do the energy audit that Josie referred to, and do the low-hanging fruit stuff. But what I would say is there is a point, depending on where you live and what is happening, if all your neighbors are putting in photovoltaic panels, there's a point where you might have too much instantaneous energy when the sun is shining, and your job is actually now to store what all your neighbors are putting up. There's a point where it's not just this obvious thing like, oh yeah, I'm just going to do net zero and just put PVs up. You might actually be better off time shifting and taking that excess solar when no one's around there and using it. If the entire electricity grid of Xcel Energy has all this wind and solar and your neighbors do, someone needs to store that for when it's dark out and the wind isn't blowing. Because otherwise, what's going to be on is Xcel Energy is going to keep those combined cycle natural gas plants running. They're not going to retire them. They're maybe not going to run them at 80 to 90% utilization. They'll keep them running, and then when you hit a peak day, they're going to fire them up. So you have to realize that, okay, we may not be using them all the time, but what you do when you choose to charge your car, when you choose to take a hot shower. Josie showed some of this in her smart appliances and flexible load strategies. If we all charge our cars at the same time, you create this spike on the grid. And that peak demand, if we don't have that capacity, then those coal-fired plants that are idle or those gas combined cycle plants will then kick in. So that is still a thing that we have to consider, is what the marginal fuel source will be for those times.
No, that's a great point, and
it's nuanced. I'll agree, but
yeah,
it's not as straightforward that, oh, I should just put PVs on my roof. You might be better off finding out that actually it's a lot less sexy, but maybe I'm going to put in a heat pump water heater that's grid interconnected, and it can actually read the carbon signals coming off the grid to say, oh, it's actually going to delay turning on, and it's actually going to, it realizes that there's a low carbon signal happening right now. It's going to overheat the water and then let the tank ride and idle until it's needed to get through that peak period. So more grid interconnection. And I think you're going to see this little bit of altruism, and I don't know how it's going to be incentivized, but instead of people asking what their grid can do for them, it's what can I do for my grid?
Well, and one question that certainly hangs over all of this discussion is cost, both at the micro level of individual homeowners, but also the state governments. And the budgets, of course, are stretched right now because of COVID. And we hear about some initiatives or maybe legislation that's moving through in Colorado right now. So maybe you could speak to the idea of what is the optimal balance between state agencies stepping in and taking care of funding some of these changeovers through credits or rebates or other mechanisms versus having it come through the private sector and through investment. Maybe Josie, to you first.
I think this is complicated enough that it needs to be worked from a variety of angles in an incremental kind of way. So everything is going to kind of keep moving upward, and we can already see that happening. The codes are getting increasingly stringent. The leadership that's being provided by visionary organizations and developers is getting more ambitious. So we see solutions coming from private sector, and we see the technology starting to shift and change, as well as starting to kind of raise the floor. So we kind of need to raise the ceiling and raise the floor simultaneously. And that's part of how we get there. So it's not one or the other. It's kind of all of the above.
And then, of course, there's the accessibility question as well, making sure that underrepresented communities are not being left behind in any kind of ongoing energy transition when it comes to structures.
Trent, can I speak to that for 1 minute?
Yeah.
So I helped to facilitate a just transitions table, and we had labor unions and environmental groups and racial and social equity groups and faith-based organizations at the table. And we talked a lot about what it means for communities who are currently very fossil fuel dependent, as well as for those who don't have resources and who have been historically marginalized and taken the brunt of environmental pollution. And one of the things that resulted from that was a just transitions position at the governor's energy office, looking at how we can do effective workforce development and training for those who are currently in the energy sector, as well as for community members who are at the lowest economic tiers. Looking at glide paths and ways out of the energy sector for those who are towards the end of their career. So there's tremendous opportunities there, as well as looking at how do we prioritize and make available energy retrofits to the lowest income houses and households in the country. So as we prioritize how to work with that existing building stock, how do we prioritize increasing the number of low-income homes and residences that are energy efficient, thereby serving those in most need first?
Absolutely. A question for Mark about news organizations and public information journalists. How would you characterize the way that the media covers energy, for example? Is the information out there good? Is it undercovered? What would be your assessment?
Jamie, what do you think?
Yeah, I tend not to follow general news outlets for that. So I'm in a nuanced segment, and that's tend to be where I get my news. I would say that, the Denver Post, New York Times, they could do a decent job. I saw an article in the LA Times that talked about building electrification, and I thought it was the best piece. I wrote to the author that I can't believe that this came out of a general media outlet. That they dealt with everything so balanced and gave all the sides, and it happens. So there are some writers out there that do get the nuance, and editors are giving them the space that they could print it. But I don't have a specific. I don't know, Josie, if you do, or CPR, anyone comes to mind.
I'm pleased to see the degree to which issues around energy and climate have been increasingly covered by news media and journalism. It's going to be a topic for a long time, and so continuing to find ways to make that relevant and fresh and interesting to readers is going to be important because this is the long game. So I think we've made great strides, and we're going to have to keep after it for a long time.
Definitely. Well, I think we could definitely talk for a whole other hour about all of these topics, and there's so much more to get into. It's just an incredible space to be in, and I want to leave you both, as we come up on our time here, with an opportunity for maybe a final word of optimism, of something that you're going to be watching for over the next, let's call it 5 to 10 years. Things that are going to be interesting to you to see how they play out as we head toward those 2030 and 2050 benchmarks that Josie mentioned. So maybe Jamy, we'll give that one to you first, and then to Josie for the last word.
All right. I was looking up the gas ban article for somebody in the chat. Repeat the question, Trent.
Oh, it's something that you're going to be really interested in over the next 5 to 10 years, something that you are just super interested to see how it plays out, or something that you're watching for in particular.
I would say the decarbonization of the electric grid and the rollout of EVs on how that's going to go. As a homeowner in Cap Hill, in a house that has a steam radiator system, I am trepidatious but excited to figure out how this building is going to get converted, because it's not just mine, it's a multifamily building, how it's going to get converted. So there are huge hurdles that I see for all of us to take this path together. And I'm hopeful that our state legislators and advocates will all work together to come up with good policy to get us there, so that we don't all go back to our separate tribes and entrenched groups and fight on this.
So I agree with Jamy. This move toward electrification and the transformation of the grid is huge, and pair that with bringing in efficiency and smart grid technologies. All of those are really massive shifts. And I guess I would just add to that, layering in the notion of equity and how we can start to bring that more fully into the conversation and more forward in the conversation, and begin our energy transitions and energy solutions with those who are most in need. The introduction of that into this conversation over the last several years, and how that's going to play out into the future, I think is both really important and really interesting.
Yeah, very well said. Well, I want to thank both of you for your time and your expertise today. This has been a terrific conversation. I know that I learned a lot, and I'm sure our audience did as well. So thank you both, and we'll hope to stay in touch with you down the road.
Thanks everyone for showing up today, and thank
Thanks.
you, Trent, and to the museum for hosting us. Really appreciate the opportunity to be here.
Of course. Well, I want to thank our audience as well. Thanks for spending part of your afternoon with us. We really appreciate your support of this series. And as I mentioned previously, this recording will be available on the Institute for Science and Policy's YouTube channel. So if you want to go back and catch anything that you missed or share it along, that would be terrific. The Institute is on all the usual social media channels. You can find us on Facebook, on Twitter, on the web at institute.dmns.org. We'll be back next month, exactly 4 weeks from today, talking specifically about nuclear power. Very controversial, lots of possibilities perhaps. How does it play into a potential decarbonization? We'll be talking about that on March 16th. So we'll hope to see you then. And on behalf of all my colleagues at the Institute and at the museum, hope you have a great rest of your afternoon. Thanks, everyone.